Imagine that 4 billion years ago, the Earth, our home, teeming with life, was a boiling ball of lava. No life. No water. Just a ball of fire. There are several intriguing questions raised by this change from a molten world to the prosperous planet we know today. From where did water originate? How did the moon form? How did it all start? We need to go back 4.6 billion years, before the solar system was even created, in order to comprehend this. The solar nebula, a huge cloud of gas and dust, and dark, empty space were all that existed in the universe back then. This nebula, which was dominated by hydrogen and helium, floated in peace until a nearby star burst into a supernova, releasing shockwaves that broke the nebula's tranquility. A rotating disk known as the protoplanetary disk was created as portions of the nebula collapsed due to gravity as a result of this disturbance. Heat and pressure built up at its core, forming a protostar. Our Sun was eventually created when nuclear fusion erupted in this protostar. Just 0.2% of the nebula's mass remained after the Sun destroyed 99.8% of it, leaving the remaining 0.2% to create planets, moons, asteroids, and comets. Through a process known as accretion, dust particles in the disk collided and adhered to one another, developing from clusters into planetesimals and subsequently protoplanets. Earth, a spherical mass of molten rock, formed over millions of years as a result of these intense collisions. Earth's turbulent early years were known as the Hadean Eon, and they lasted from 4.6 to 4 billion years ago. The Earth was inundated by comets and asteroids, which brought water and gave rise to the first oceans. In addition to producing tremendous heat, these collisions melted rocks into magma oceans. These incidents created the conditions for life despite this raging mayhem. The interior of the Earth started to differentiate in the meanwhile. Lighter elements rose to form the crust and mantle, whereas heavier elements, such as iron and nickel, sunk to form the core. An early atmosphere was created by the release of gases like as carbon dioxide, methane, and water vapor during volcanic eruptions. Large seas formed as a result of rain filling the basins and water vapor condensing when the Earth cooled. However, how was the Moon formed? The giant impact hypothesis is endorsed by the majority of scientists. Theia, a protoplanet the size of Mars, collided with Earth some 4.5 billion years ago. The Moon was formed by the coalescence of impact debris, as the cores of both planets fused. Seasons were created by the tilting of Earth's axis caused by this collision, which also stabilized the planet's rotation. Earth started to take shape by the Archean Eon, which lasted between 4 and 2.5 billion years ago. The first oceans emerged as the crust, mantle, and core layers completely developed. Life was made possible by the stabilization of Earth's temperature brought about by volcanic activity and the greenhouse effect. Another important factor was the Earth's magnetic field, which was produced by its roiling iron core. It helps preserve our atmosphere, which is necessary for life, and protects us from dangerous sun radiation. We wouldn't have tides without the Moon's gravitational pull, which was essential for the movement of life from the waters to the land. The history of Earth is a masterwork of cosmic fortuities. The Sun is just far enough away to warm the Earth without burning it or making it too cold. Because of its size, Earth has precisely the appropriate amount of gravity to sustain an atmosphere. Volcanic activity prevented Mars-like cold or Venus-like heat by balancing the greenhouse effect. Life can thrive because the magnetic field shields us from lethal radiation. Since all of these conditions had to be met, Earth's trip was truly remarkable. It serves as a reminder that we have a duty to preserve our planet since it is special and valuable.